So let's understand vector databases. Vector databases is nothing more than simply storing whatever data you're throwing at the system into numbers, right? A list of numbers, as simple as that. And what it helps is it helps in remembering and comparing the meanings of, let's just say, whatever the data that you have shared. It could be text, it could be audio, it could be video, it could be images and whatnot, right? So yeah, first and foremost is everything is turned into numbers. So whatever phrase that you throw at it, let's just say, I love mangoes, that is converted into a long list of numbers called a vector. So something like this, right? Next, what it does is it stores these numbers in a database, and that's basically your vector database, right? And finally, whenever the LLM tries to query the database, what it does is it doesn't necessarily go for a one-to-one match, which would take a long time, as you can imagine, right? If you start comparing phrases on words per se. But what it does is it compares those vectors or those lists of numbers to identify what is the nearest match that is possible, which makes retrieval and storage very efficient. Now let's come to n8n, right? And what we'll do is we'll take the example of Pinecone as a vector database today to understand what it powers, right? Empowers. So as you can see, there are two actions that basically a vector database can do. One is storage. So as in when you throw a text or an image or some kind of a data, it will store that data. And then retrieval, right? Efficient retrieval. So we have to plug in an LLM, and an LLM can basically pick out the data from that vector database and quickly be able to respond to you. So this is the first one, right? Let's just say what I've done is I've hooked it up with my Google Drive, which has a few documents, and then it's basically thrown into a vector store. So if I click on plus and I search for Pinecone, it basically gives me this Pinecone vector store. Here I can say add documents to vector store, right? This is the action I will perform. So when I click that, this node opens up. If I open it, first and foremost that I want to do is Pinecone API account, right? For that, click create a new credential and you have to put in the API key. So for this one, what we'll do is we'll go to the Pinecone website. So this is how it looks like when you open Pinecone. What you can do is sign up using your Google account. So once I've reached my homepage, this is pretty much how it looks like. I can click on indexes. And first I have to do is create an index over here, right? Click on create index, name it something like, for example, rag chatbot. I'll select the text embedding 3 small model by OpenAI because this is very efficient. Dimension, I'll keep it as 1536. I'll scroll down, rest everything remains the same. The other cloud providers probably are paid, so I'll keep it to AWS. Everything remains the same and I can click on create index. So this will create an index for me, which is basically the highest level of storage, you can call it. Next up, I'll just click go and create an API key. So like click on API keys and here I can create an API key, right? For example, something like test. That's all. It will basically give you this. You can show it, copy it from here, and then go back to your n8n flow. And here you can copy paste this API key, right? That's all. Click on save. It will basically create that new credential for you. And then here the operation is insert document because I'm collecting information for the first time. Pinecone index, I just created it. So for example, RAG chatbot, right? The one that I created right now. I can select this one. Embedding batch size could be 200. And then namespace. So this is basically a finer level, granular level storage space, right? This is something that I can name. So for example, for this chatbot I'm creating for a company, I can name it as company docs. And then that's all. Next up is embedding model. So I'll create an embedding model over here and make sure this is selected to text embedding 3 small, which is something that I selected earlier, right? In Pinecone. And next up is data loader. So default data loader is something that I'll select. JSON, load all input data because I want to store everything that I'm sending. And text splitting is custom. And then token splitter, I'll just have a chunk size of 100 and chunk overlap of 0. That's all. So when I do that, as in when you hook it to a cloud storage or some kind of a file, right? Whatever is the input from that will be stored as vectors in this vector DB. So if I go back here and I go to databases, for example, Remger is where I stored some data, right? Let me open this one. In namespaces, you'll basically have this company docs, which has Spotify records, for example, something that I've stored. So you have this information. So that is step 1. Step 2 is retrieving information from this one, right? So you have stored data, now you have to get it back. What I'll do here is that typically this is the flow that looks like. You can probably have a webhook to listen to it to create a voice agent, or let's just say you can even hook it to a chat, right? Chat model, something like that. But basically, you create an AI agent, right? An AI agent node from this plus, as you might be knowing, AI agent. And then in tools, connect it to a Pinecone vector store again. So you can click uh, the plus button over here and then type in Pinecone vector store over here. When you click that, this will open up. Again, connect your Pinecone API account, which you created in the earlier step, and retrieve documents. Now this time, right? You have to retrieve the documents, not keep or embed the documents back. And just put in a brief description, right? So call this to retrieve information about Remger company, like about the service systems or conditions of privacy policy. Select the right index that you created. Limit could be 1000 metadata, and finally the namespace. Again, add an option to query the exact namespace that you want. And finally, tag it to an embedding model, right? So this could be again the text embedding 3 model, the small model that we initially used for creating those embeddings. So retrieving will also require the same one. And that's all. You are good to go now to even create those vectors inside this vector database or even retrieve it. Thank you for joining.